Hi everyone. So this video is kind of just to give you a little bit of an overview of 3.2. So I know that we did a lot with these patterns, and sometimes if you don't look at them as a big picture thing, it can get a little confusing as to where these equations even come from. So I want to just take a step back and do a little bit of some practice together. So our learning target, right, is 1a.1.1. So we're writing explicit equations of quadratic functions given a visual pattern. So you'll notice there's four separate examples here that we're going to talk through in this video. And these are all examples that we've actually done before, whether they were in some of the tasks that we did or in the practice examples that you worked on your own. So let's take a look at the first one. In these examples here, I'm going to show you kind of two different strategies for organizing your work. I know that I've been really focusing on creating a table with my students. And if that's not working for you, then I do want to show you another way of kind of organizing your work and thinking through the problem. But if the table is working for you, then I want you to stick with the table. So I'm going to kind of show you both, and I want you to do what works best for you. So in this first example, I'm going to start by making my table, and I'm going to call it x and f of x. X is going to be my figure number, and f of x is going to be the number of blocks in the figure. So I've got figures 1, 2, and 3. Now we want to keep in mind that we're always going to be looking for squares, right? Every single time we write a quadratic equation from a pattern, we're going to be looking for squares. And so, yes, all of the little figures in all of these are definitely squares, right? But we want to look at the big picture here. So what that means is in the first figure here, yes, there's one square. Like I totally get that, right? We can easily count it and be like, bam, there's one, we're good to go. But I want to emphasize that it's a 1 by 1 square. In figure 2, we can see that there's this 2 by 2 square in here. And that actually helps me count how many squares there are faster, right? So we said in figure 1 there was 1 square. In figure 2, it's this 2 by 2 square. Well, 2 times 2 gives me 4. So there are 4 blocks in figure 2. For figure 3, we can see there's this 3 by 3 square. If we look at the big picture here, right? We could count it individually, but why waste our time, right? If it's a 3 by 3 square, I know that there are going to be 9 squares in that figure. So again, this should look familiar to you because we have done this. And this is also the most basic quadratic function that we can actually work with, okay? So what I'm going to do next is using my table, I'm going to break down these numbers that I found into those perfect squares that we said. So in figure 1, it was a 1 by 1 square. And I know if I've got 1 and I multiply it by itself, that's really 1 squared. In figure 2, I had a 2 by 2 square, which can be written as 2 squared. And in figure 3, I have a 3 by 3 square, which can be written as 3 squared. So now what I'm going to do is I'm going to think about what's the pattern that I see. Well, I started with 1 squared, then I did 2 squared, then I did 3 squared. And if I were to go to the next one, my bet is that it would be 4 squared, and then 5 squared, and then 6 squared. It's always just going to be some number squared. So when I go to write my equation, I'm going to start by just writing that. It's going to be some number squared. I don't know what that number is yet, and that's okay. I'm going to figure it out. But I can recognize that my pattern is showing me it's always going to be something squared. From here, we want to look at how is the figure number, so 1, 2, and 3, how are those numbers related to what's being squared? So we start with 1 squared, go to 2 squared, go to 3 squared. Well, in figure 1, I did 1 squared. In figure 2, I did 2 squared. And in figure 3, I did 3 squared. So the figure number happens to be the number that I'm squaring, right? Like they're the same number, which means in figure 4, I would do 4 squared. In figure 8, I would do 8 squared. In figure 101, I would do 101 squared, right? It's always going to just be the figure number. So this is the same as the figure number. And so what that means is if I want to write my equation and I want figure x, it's simply going to be x squared. And you can write it without the parentheses if you want, literally just x squared like that, and that's totally fine. So again, this is the most basic of the quadratic functions that we can have, all right? But we have to look for those squares, and then we have to figure out what's the pattern that we notice here. So in this case, the figure number and the number that we were squaring happened to be the same. Let's take a look at another example. In this second one, you'll notice some of these figures actually look the same, right? This first figure here actually looks exactly like figure 2 from the previous example. We've got a 2 by 2 square. So 2 by 2, then we've got in the next one a 3 by 3. And finally, in figure 3, we have this 4 by 4. And actually, instead of using the table in this example, I am going to show you just kind of another way to organize it. So if you like the table, stick with the table for sure. All right. In this one, though, figure 1, we said was this 2 by 2 square, which we know can be written as 2 squared. So yes, there are 4 squares in this figure, and that's important. But really, I need to look at the big idea here, right, at the pattern. So I'm not going to write the 4. In figure 2, we have a 3 by 3 square, which means I can write that as 3 squared. And in figure 3, we have a 4 by 4 square, which can be written as 4 squared. When I take a step back to look at what is happening here, I can see a 2 squared, a 3 squared, and a 4 squared. My bet is the next figure, figure 4, is going to be 5 squared, right? If my pattern continues, it's always going to be some number squared, very similar to what the last one was. Now I just need to figure out what is that some number and how do I write my equation then? So to do that, we go back to the figure number. In figure 1, we did 2 squared. In figure 2, we did 3 squared. And in figure 3, we did 4 squared. Well, that's not the same as the last one, because in the last one, the figure number was the same number that we were squaring. In this case, that is not true, and we need to figure out how these are related then. Well, figure 1, if I just add 1, that'll give me the number that I'm squaring. In figure 2, I'm squaring the number 3. 3 is 1 more than 2. In figure 3, I'm squaring the number 4. 4 is 1 more than 3. Which means if I take my figure number and add 1, that's the number that I'm squaring. So this sum number that I'm talking about here is going to be 1 more than the figure number. So if I want to write my equation, f of x, x would be my figure number. So it's going to be this thing squared. And this thing is one more than the figure number. So if the figure number is x and I want one more, that means x plus 1. So it's kind of another way that we can organize our work if the table is getting a little confusing. So either way, whatever makes more sense for you to be successful. So taking a look at these two examples that we've done, they both were just this thing that was being squared. And we just needed to figure out how is this thing that's being squared related to the figure number. In one of these cases, it was the same as the figure number, so it was just x. And in the other one, the thing being squared was one more, so it was x plus 1. But I think it's important for us to be able to see these two examples side by side and see how they're similar and different to each other. Moving on to our next example here, you can see it's actually kind of color-coded for us, which is kind of nice because if you look at the things that are color-coded, you've got a 1 by 1 square, you've got a 2 by 2 square, and you've got a 3 by 3 square. And then when we look, there's just this extra square here to the side on all three of them. And it's the same in all three of them, right? It's just always this extra square over on the side. But what's really nice about that is that helps us get to our quadratic equation right away. So whether you want to do the table or the other strategy for writing this, it doesn't matter. X is going to be our figure number. F of x is going to be the number of squares, right? In figure 1, we've got 2 squares. In figure 2, we've got 5 squares. And in figure 3, we've got 10 squares. So again, if the table is your strategy, then here we go. In figure 1, we've got this 1 by 1 square. And then we have another random square being added. In figure 2, we have a 2 by 2 square with another one being added. And in figure 3, we have a 3 by 3 square with another one being added. When we take a look at that, we know 1 times 1 can be written as 1 squared. 2 times 2 can be written as 2 squared. And 3 by 3 can be written as 3 squared. So we started with 1 squared plus 1, then we did 2 squared plus 1, then we did 3 squared plus 1. If we start to look at our pattern here, it's always going to be some number squared and then plus 1. So we just need to figure out what is this some number, right? And again, we can see this in our pattern, right? It's a number squared, and then it's always going to be this plus 1. And that's the green one that we see. So the plus 1 is from right there, and the square is that pink thing I highlighted there. So we just need to figure out what's this thing that's being squared. Well, when we look at figure 1, we're squaring the number 1. Figure 2, we square the number 2. Figure 3, we square the number 3. If we look at that, the number that we're squaring is always the same as the figure number. It's actually exactly like what we did in the first example here. The only difference is we've got this other plus 1 at the end, but that's okay because that's just part of our pattern. In terms of the number that's being squared, this number is the figure number. So when we go to write our equation, it's the figure number, which is x squared, and then plus 1. And again, it's the figure number, so it's just the same thing there. And then we add the 1. And of course, we have the square. Sorry, forgot to say that. If you prefer to organize it without the table, that's totally fine too. We'd have our 1 squared plus 1. Then we'd have our 2 squared plus 1. And we'd have our 3 squared plus 1. But again, we recognize, oops, got to change the color there. Sorry about that. The plus 1 is always there, and the squared piece is always there. So we just need to figure out what that thing is that's being squared, and it happens to be the figure number. Finally, for our last example here, this one was one of the ones from the practice. So we're going to take a look for those perfect squares. Now, I think it's a little bit hard to see in the first picture, to be totally honest. So I'm actually going to jump to the second picture, but I can see right here that there's a 2 by 2 square, right? And I'm going to do it with my pen instead. Sorry about that. So I can see that right here, there's a 2 by 2 square. Then underneath it, there's another 2 by 2 square. And underneath that, there's another 2 by 2 square. So there's a 2 by 2 and another 2 by 2 and another 2 by 2. Well, I can write that as 2 squared plus another 2 squared plus another 2 squared. Well, if I'm adding the same thing together 3 times, then I can just multiply that. I see 3 sets of 2 squared. So let's see if that works in my other pieces. In figure 3, here's a 3 by 3 square. And then underneath it, there's another 3 by 3 square. And underneath it, there's another 3 by 3 square. So there are 3 3 by 3 squares in this figure. And the way I can write that is by doing 3 times 3 squared, right? 3 sets of 3 squared. In figure 1, then, we can look at it and go, oh, well, this is a 1 by 1 and a 1 by 1 and a 1 by 1. There are 3 1 by 1 squares. So I know that this one is a little bit harder to see, but we can still see the same perfect squares in here that we see in all of these other patterns actually, right? It's just that there are multiple sets of them, which is why we multiply it, right? There are 3 sets of perfect squares in each of these figures. So when we look at writing a pattern here, it's always 3 times some number that's squared, right? 3 times 1 squared, 3 times 2 squared, 3 times 3 squared. So we just need to figure out what's going on with this number, right? How is it related to the figure number? So in figure 1, we did 1 squared. In figure 2, we did 2 squared. And in figure 3, we did 3 squared. So the number that's being squared is just going to be the figure number, just like it was in example 1 and in example 3. So this number needs to be the figure number. When I write my equation then, f of x is going to equal 3 times x squared. You can write it without the parentheses if you want. That's totally fine. Since I put the parentheses in the other ones, I kind of just put it there as well. Again, if you prefer to organize your work in the table, that's totally fine. You can do it that way. I think that that's a really great strategy. But if doing it without the table works for you and is helpful, that's totally fine. So remember, in all of these problems, you're looking for those perfect squares. And sometimes, like what we did in example 3 over here, sometimes you have the perfect square plus just these random other things that are being added to it, right? Or sometimes, like what you have in example 4 happens, where you have multiple perfect squares, and so you have to do some number times those squares. Or you've got some of the more basic ones, which are just a number being squared. You've just got perfect squares in your figure. Okay, hopefully that helps clear some of those questions from 3.2 up. Please reach out to your Math 2 teacher or your foundations teacher if you're in foundations. Please reach out to them and ask for help if you need it so that you are ready for this upcoming summative. Thanks so much for watching.